All right, here we go with number 11. Okay, given that the tangent of x is negative 5 over 12. All right. Excuse me. And cosine of y is 7 over 25. Wow. Both angles x and y are in quadrant 4, so let's draw ourselves two separate triangles here. Okay. Quadrant 4, x. All right, tangent is opposite over adjacent, so I have opposite over adjacent. And remember, if I'm going down, this needs to be negative. Triple, 5, 12, 13. All right, cosine of y, 7 over 25. Here's y, 7, 25. Then this should be negative 24, 7, 24, 25. All right, so we want to do the cosine of x plus y. We want to use our cosine sum formula. The cosine sum formula is this: cosine x times cosine y minus sine x sine y. All right, so the cosine of x is adjacent over hypotenuse, so 12 over 13. The cosine of y is given to us, which is 7 over 25. Minus the sine of x, which is opposite over adjacent, opposite over hypotenuse. So negative 5 over 13. And then opposite over hypotenuse, negative 24 over 25. All right. 7 times 12. Oops. 84 over 325. These two negatives make it a positive, so it's still minus, and it's 120 over 325. Same denominator, common denominator, 84 minus 120, you get negative 36 over 325. Wowee. All right, so don't make the mistake, all right, cosine x plus y, just writing cosine of x plus cosine of y. Remember, we have to use our sum formula here. All right, cosine of x, which is 12 over 13, times the cosine of y, which is 7 over 25, minus the sine of x, negative 5 over 13, times the sine of y, which is negative 24 over 25. All right, be careful with your signs. That's some place where a lot of people can make a mistake. Okay, yeah. Sine of 2x. Now, this is not equal to 2 times the sine of x. So don't make that mistake. All right, we need to use our double angle formula, which is 2 sine. This is just great. Why does this happen to me? Why does this happen to me? Sine x times, do I just write too fast? Oh! I'm going to lose it. Look at that. Cos x. I'm going to lose it. So I know the sine of x is opposite over hypotenuse, negative 5 over 13. And I know that the cosine of x is 12 over 13, adjacent over hypotenuse. Now be careful when you're multiplying these fractions together, all right? Remember, this is 2 is equivalent to 2 over 1. So 2 is only being multiplied to the numerators up here. So it's 2 times 5, which is negative 10. Negative 10 times 12 gives me negative 120. 1 times 13, which is 13. 13 times 13 gives me 196. Yeah, no, 169. Why did I say 196? I knew that looked wrong. All right, so let's move on to next one. 12. 12. All right, so we have a binomial times a trinomial. We want to distribute this 4x to everything in our trinomial. So 4x times 6x squared is 24x cubed. All right, 4x times negative 7x gives me negative 28x squared, and 4 times negative 3 gives me negative 12x. Negative 5 times everything. Negative 5 times 6, negative 30x squared. Remember last time I said to line it up like this so it's easier to combine your like terms. That gives me positive 35. Now you don't have to do that. I just like to do that so it's like I'm adding straight down. Remember? 24x cubed. Negative 28, negative 30, negative 58x squared, negative 12 and 35, plus 23x plus 15. All right, solve the triangle. Okay, so I'm given triangle ABC. All right, where A is 10, B is 7, and C is 5. So A, B, C. A is 10, B is 7, and C is 5. So I have side, which means I have to use the law of cosines. All right, law of cosines. I'm going to use A squared equals B squared plus C squared minus 2BC cosine of A. You could have done any of the variations here. Okay, it does not matter. All right, so I do A squared, which is 10 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cosine of A. 10 squared is 100. Come on, dude. 49 plus 25. It's unreal. Unreal. Just a great day today, huh? Let's have a great day. That's a 70 cosine A. Subtract these over, subtract 49, subtract the 25, I get 26 equals negative 70 cosine of A. Divide by negative 70, I got negative 0.37142 equals cosine of A. The more decimal points I write, the more exact my answer is going to be. In order to find an angle measure, I have to use the cosine inverse function of that decimal. Just as a reminder. Obviously, you don't have to write this step. I just want to remind you that. So A equals, what did I get? 111.8. I can't deal. Oh my God. So I got 111.8 degrees. Okay, so now I want to use angle A and the side A. What did I write? This should be 5. Let's see. All right. To help me find one of my angles. You could pick either B or C. I picked B, so I'm going to use my law of sine. So sine of 111.8 over 10 equals sine of B over 7. So 7 times the sine of 111.8 equals 10 times the sine of B. B divide by 10 and use your sine inverse. I got b to equal, I can't do this, I can't. B equals, I got 40.54 degrees. If I know this is 40.54 and this is 111.80 to find C, I subtract it from 180 to get 27.66 degrees. All right, there's that one. 14, we got 2 more to do, 5 minutes left. All right, 14. This is going to be, we're only finding the measures of angle A. Measures of angle A. So if you look at this here, all right, I got triangle A, B, C. Angle B is 58 degrees. A is 12.8 degrees, and B is 1 or 11.4. So I have a side angle, okay, which tells me that I have to use, this is an ambiguous case, so I'm going to have 2 possible triangles. So I first want to find this, my first A, my first angle A. So sine of A over 12.8 equals, actually I'm going to need a lot of time for the next one, so I'm going to pause this and I'm going to show my, alright, so as my final answer here, I got A to equal 72.21 degrees. You can see my work here. Alright, now, remember when we talk about this ambiguous case that we have to find the angle that is supplementary to this? Because within our unit circle, if we think about our unit circle, alright, if this is 72 degrees, right, sine is going to have a similar value at another place. Well, it's going to be that other place over here. Okay, well, how do I find that? It's the difference. If this is 72, then this angle has to be 72 as well. 72 is our reference angle. I do 180 minus 72 to find my other A value. So A prime is 180 minus 72.21 to get 107.79 degrees. Alright, here we go. So I'm going, from where she's standing, Claire measures an angle of elevation to the top of the building, which is 43 degrees. Alright, someone is 800 feet closer. Alright, so here is my triangle with just Claire. Here's Claire. This is 43. The hardest part's the picture. Alright, so then there's a person that is 43, or 850 feet closer. So 850 feet, if this is Claire, 850 feet closer would be our new person, and this angle of elevation is 61 degrees. Alright, well that tells me that if this is 61 degrees, then I could find this because they're going to be supplementary here. Okay, this angle should be 119. Alright, 3 angles in a triangle have to add up to 180 as well. So I need to find the measure of this angle, which I got to be 18 degrees. Okay, we're trying to find the height of this building. So in order to do that, we need to know what the length of this side is first. Alright, so we can use this right triangle here. So to find the length of that side, I'm going to use the law of sines. Okay, and I'm going to set that work up right now. Use sine of 18 over 850 equals sine of 43 over x to find this side length. Did my work and got 1875.94. Now that I know the length of this side here, okay, I can use this side to help me find the height of my building. Alright, I can do that 2 ways. I can use the law of sines. We can assume that this is a right angle, and I can find the measure of that angle. Or I can use right triangle trig. I'm going to show you both. You pick which way you want. Alright, so here's my law of sines work. Either way, you'll notice that I'm going to end up multiplying 1875.94 times the sine of 61. Alright, I'll do that same thing here if I cross multiply. Because when I divide by the sine of 90, well, the sine of 90 we know from the unit circle is just 1. Alright, so here's my work for that one. Hopefully this one helped. Make sure you do this a couple of times maybe because it was a struggle on our last test.